to find the angle between vectors in space, we simply have to apply what we learned in 2 dimensions and apply it to 3 dimensions. So we know that the dot product, sorry, bad pen. We know that the dot product u dot v is also equal to the magnitude of u times the magnitude of v times cosine of the angle between them. Now I have to put both of these vectors tied tail to tail, or put their initial point on the origin for this to work. That'd be that 0, 0, 0 point. Doesn't really matter. I could put them anywhere, but traditionally we put them at the 0, 0, 0 point, by convention, by the way. So if I put them tail to tail at that point, the angle between them can be found by using this formula, which implies, of course, that cosine of theta will be equal to the dot product over the magnitude of u times the magnitude of v. So in this case, cosine of the angle would equal, well, the dot product of these two would be x component times x component. So that'd be 1 times 3 plus y component times y component, 0 times 1, plus z component times z component, 2 times 0, all divided by the magnitude of u, which would be the square root of 1 squared plus 0 squared plus 2 squared, times the magnitude of v, which would be 3 squared plus 1 squared plus 0 squared. Now, considering this denominator, I know from algebra that the square root of a times the square root of b is written as the square root of ab. I can do that when they're multiplied, not when they're added, but when they're multiplied. So I can write this as cosine of the angle is equal to 3 plus 0 is 3, divided by, this is the square root of 5, and this is the square root of 10. So to simplify that, using that rule, I could call this the square root of 50. The square root of 50, which means that the angle will be the inverse cosine of 3 over the square root of 50. And when you do that math out, you get 64.9 degrees to the nearest tenth of a degree.